Tonight we're going to begin our study on inequalities, and this is video 1 in that study. And first we're going to look at some properties. The first property is called the Trichotomy Property. It states that either two numbers are equal or one of them is less than the other. And here's what it looks like. So here's what it looks like written with mathematical expressions. For any real number a, it's either smaller than 0, equal to 0, or bigger than 0. The next property is the non-negative property, which states that any real number you square will always be bigger than or equal to 0. Next we have the transitive property of inequalities. And this property says that if a is less than b and b is less than c, then a is also less than c. So if a is less than b and b is less than c, then a must also be less than c. This also works for the greater than symbol, and I would like for you tomorrow to bring in your notes a similar picture that I have drawn, but applying the greater than symbol for this property. Our next property is the addition property, which says if a is less than b, then a plus c is also less than b plus c. And this also works for the greater than symbol. So what this property is saying is that if I add a number to both sides of the inequality, this symbol is not going to change directions. Next we have the multiplication properties of inequalities. And again, these work if these symbols are greater than also. And what these properties really state is that it says if a is less than b and then I multiply by a number greater than 0, the sign does not change, or the symbol does not change, excuse me. However, if I multiply by a number less than 0, then the symbol does change the directions. This also works if I'm dividing by a negative number. So, if dividing or multiplying by a negative number when solving inequalities, we must change the direction of the symbol. Okay, next we're going to move on to graphing inequalities. The first one, it says graph x is greater than 4, keeping in mind that x is going to be a real number. And so whenever we're graphing these, we just need to remember to put a 0 on our number line. And then the only other number I'm concerned about is the number that they have in the inequality, which is 4. Now, since this symbol says x is greater than 4, I need to shade the line in the right direction. So it will look like this, shading that way. And since 4 is not included, I make an open circle. Our second example, graph x is less than or equal to -2, getting my 0 and -2 on my number line. Because 2 is included this time, because it says less than or equal to, this little line here, I need to have a closed circle on -2, and everything less than -2 is to the left direction, and so I shade that direction. Now we might also see some inequalities like this we have to graph. They're combined inequalities, sometimes also called compound inequalities. And so it says graph all real numbers x for which x is greater than 4 and x is less than 6. So I'm going to include a 0 on my number line, as I always do, a 4 and a 6. Now, numbers greater than 4 would be going this direction, but numbers less than 6 would be going in the opposite direction. And so we're going to shade in between those two parts. Similar to the previous example, we have this combined inequality, which says graph all real numbers x for which x is greater than 4 or x is less than or equal to -1. So if I'm graphing x is greater than 4, I have an open circle because it's not equal to, I know that that would go to the right. If I'm graphing x is less than or equal to -1, closed circle, and numbers less than -1 go to the left. So my shading goes in the opposite directions. Lastly tonight we're going to look at interval notation. First is the closed interval. And a closed interval has brackets, and this means that it includes every real number between a and b, also including a and b, which is why we use the bracket. The open interval uses parentheses. Also, this is every number in between a and b, except this time a and b are not included. Half open and half closed are terms that mean the same thing and are denoted by two different interval notations. The first is when a is not included, but b is. The second is when a is included and b is not. So in inequality notation, the first would look like this, where we have equal to by the b, and the second would look like this. These last 5 interval notations use the infinity symbols to indicate unboundedness, either in the positive direction using this symbol or the negative direction using this symbol. Now keep in mind that infinity is not a real number, just a notational device that we use to represent that unboundedness. And so the first one we have includes a and is unbounded in the positive direction. So using an equality, we would write this in this way. We would have any number x that is greater than or equal to a. Next is unbounded also in the positive direction, but as you see with the parentheses, a is not included. And so we would write this as any number x which is just greater than a. Next we have unboundedness in the negative direction, including a, by the bracket notation, and we would write this as x is any number less than or equal to a. Next, also unbounded in the negative direction, but not including a, would be x is less than or equal to a. And the final notation goes from negative infinity to positive infinity, and that would include all real numbers. Alright, now, in addition to the transitive example, I would like you to write from at the very beginning of our presentation. Also, for number 1, please write this in interval notation, and for number 2, please write this using an inequality. And I'll see you tomorrow.